Okay, it's 11 o'clock. It's one of those mornings where everything wanted to update. So I'm not sure. So OBS updated last night. Windows now wants to update. Chrome updated. Discord did something. It's one of those mornings. Office did something. Apparently Office was down from like 5 o'clock to 9 o'clock last night, the online syncing. So it's one of those mornings where everything wants to update. We'll see what goes on. And on that line, also there was confusion regarding the quiz for today. As a result, I already made an announcement. There's you can retake it for full points until Friday at midnight. Just use the exact same quiz you did before. That seems to. So what I wanted to do was, and I was very proud of myself because everyone said that they wanted. Not everyone, but a bunch of people said that they wanted more time for the quizzes. And one person said, well, why don't you release them both on the weekend so that we'd have both Monday and Wednesday's quiz at the same time? And I thought, oh, that's a great idea. So I was so proud of myself this weekend. I did that. I posted the, granted I did it late, but I posted 6A and then I worked on 6B and I got 6B all set up. And then I posted 6B and then I forgot about it. Well, it turns out I posted 6B to the wrong class. You were supposed to have it on Sunday. You were supposed to have both quizzes over the weekend, and I messed it up. So there was a big confusion about 6B. So I got it. I went ahead and I extended it to Friday. I will be trying again this weekend to get both 7A and 7B up probably by Saturday, hopefully by Friday. But yeah, so I messed up. I'm trying. There's this whole online thing. Everything takes 4 times as long, so I have a little bit less time to do the stuff I really want to do, which is teach and, help you individually. And the whole thing is just silly. But, well, not silly. I mean, it's horrible that we're having to do this because of this virus. But, it is what it is. And I'm working on it. I'm sorry for mudding it up when I do. Anyway, let's go ahead and talk about this quiz so that when you take your retake, you can get full points because, I'm now showing you the key before you take the quiz. The retake anyway. So let's go ahead and do it. And Reflector wants to update, and so does Parrot. The things that make it possible for the communication from the tablet to the computer for broadcasting wants to update too. Everything wants to update. It's one of those mornings. Just a reminder, we have chat in Discord, which is public. We have chat in the class chat on Blackboard Collaborate Ultra, which is private. And that's it for that. Okay, so let's start about the first one. Let's state the chain rule. Now, this was one of the ones that's actually easier to use than it is to state. The easiest statement, but not really the most useful, is this one. So this is the easiest way to kind of state it on whatever. So what I'm going to do is I'm going to say let, and then I'm going to do a little drawing. I'm going to do this to this to this. And that is a mathematical object. Okay, you may do that. This actually communicates that X goes to U goes to Y. And then I'm going to say the condition if Y is differentiable at U and U is differentiable at X, then Y is differentiable at X. And dy over dx equals dy over du times du over dx. So that is the easiest way to state it. Okay? It's not the most useful when it comes to working with it, but it's the easiest way to get to just kind of state it. It actually, and it's also the easiest to remember because you just remember the du's cancel. And it's the way to remember the proof if you actually want to remember the proof, because you just remember that the change in u's cancel. So you add back a change in u on the top and to the bottom, right? You multiply by a 1, which is changing u and changing u, and then you just kind of go whoop, on the bottom. And then you have to, deal with the details. Okay, so that's the easiest way to state it, but it's not the most useful statement. The more useful statement when you're working with it, there are two. So this one is, this is the one I like. D over dx f of u equals d over du f of u times d over dx of u. That's the one I like. And then you do the same thing that you did before, where you have this kind of x to u to y. Of course, there's an if condition there, but you put an f right above the u and the y, but you don't mention anything about a g. So this is the easiest way for me to state it. I mean, that's the most useful way for me. This is the easiest way to state it with all the conditions and the conclusion. You would have to add conditions here. I'll do that on the key, but I won't really do it here. But this is, for me, the most useful. The other way to do it is to do the full thing like the book does. Of course, the book has this one too. And to do this. So that means that the way the book does it is F cert G. For me, this has too many symbols to keep track of. But, F cert G prime of X equals, and I find this confusing as all get out, F prime of G of X times G prime of X. Again, I find that extremely confusing, but hey, if you like it, go for you. Are there any questions on this one? This is actually the hardest thing to state, right? Because figuring out what the heck that means is actually pretty hard. So I find this quick one easiest when the problem is state, but I actually find this the easiest to do quickly. I find this the most useful. This is useful if you have one of those graph problems, but I find this one the most useful in general, just to work with. It's kind of a working one. Well, this is the easiest one to state. So how do we feel about that 1 to 5? And of course, they're all equivalent. I didn't do the whole thing. And of course, I have to do this. Start. So again, there are a bunch of ways to state it. I didn't include all of the other terms on this. I probably will in the key. But anyway, that's the way to do it. Okay. All right. So when it comes to these, here's how I would approach it. This is what I would do. I'd just come down here. That's nicely done here, so I won't even rewrite this. I'll just say, oh, thank you. I'm going to stick a U right here. And then what I'm going to do is I'm going to just do this, and I'm going to do chain. And I'm going to write D over du sine of u times D over dx of u equals, and this becomes cosine of u times d over dx of cosine of x, which equals, don't forget to carry your baggage, cosine of u times the derivative of that is negative sine of x. Okay, so I don't have any more derivatives. All I'm going to do is I'm going to sub in the u, and I'll pull that negative over to the other side just because it's more aesthetic. But that's unnecessary simplification, so I'll do this. Cosine of x times sine of x. So I did a little bit of aesthetic, is that I moved the negative over to the other side. I simplified a little. Okay, so 1 to 5. How do we feel about that simple chain rule? One. I say simple, not easy, but it's simple. 2A. So don't feel ashamed if you don't have it, because it's hard. It's just that one doesn't have a lot of moving parts. Okay. I always get asked, what's the bare minimum to communicate what I did? And the bare minimum would be something like this. So I do this. I say chain. I'm going to write this as bare minimum. I say chain, and then I do the derivative of the outside. So I do cosine. I will do a u here. But I would do a u there. But some people don't like to do the u. Okay. So at the very least, and I cannot stress this enough, at the very least, you must do one layer at a time. Okay? If you just wrote cosine of x times negative sine of x, it's wrong. Okay? You have not communicated your process in any way, shape, or form. Okay? I would recommend against this unless you are very fast at them. And it's something very simple. I highly recommend this way. Do not do this unless you know at the very least of what you're doing. And notice here on the bare minimum, even though, and I would use a u, but that's just b. But notice on the bare minimum, I only did one derivative at a time. Okay? So I did this chain, and I left that as d over dx of cosine of x, and then I work. So I peel it back like an onion. Now, I actually did do a u substitution here. I just didn't make it explicit. So you can get away with that on simple ones, but unless you get very good at them, you've had calculus before maybe, and you did well on it, but not quite well enough on the AP exam, I would do this method until you get used to it. This is dangerous. No, that's perfect. So the question was, if you had this answer, cosine of x times negative sine of x, that is absolutely right. In fact, I like that better. You know what I'm going to do? I'm going to make that the official answer. I like that better. That is a better answer. That keeps that negative with the sign. I like that better. But notice here that I've made very careful about the fact that there's multiplication going on here. I like that better. To me, that's the better answer. But as I said, for some aesthetics, I just kind of moved the negative over. But you don't want to do that. In fact, I would encourage you not to do it. But do make sure that you indicate that that's multiplication, not subtraction. Okay. So showing your work, again, that's the bare minimum. The communication is important. All right. So hold on, let me go back to this so that I have it up. All right, now I can stop that. So the next thing I'm going to do is this one here. Now, before I do anything, I have a cube root here. I'm going to stop that. So I'm going to rewrite the problem with the thing. So I have done nothing except rewrite the problem. Okay. That is the only thing I have done here. Now I'm going to state what my u is. So my u is going to be this whole thing here. So let's look about the journey of x here. The journey of x is the first thing that happens is that x gets logged. And then the ln of x gets cube rooted. That is the journey of x. So what I'm going to do here is I'm going to do the chain. And I'm going to do d over du of u to the 1 over 3. Right? That's the thing that happens first here. So we'll make this equal u. Times the derivative d over dx of u. Now I'm going to evaluate. U to the 1/3 is 1/3 u to the 1/3 minus 1 times d over du of ln of x. So this is 1/3. I will go ahead and simplify this in the same step here. So I'll go u to the negative 2 over 3 times, now that became baggage. This right here is, oops, that should be d over dx, 1 over ln of x. I'm sorry. And this right here becomes 1 over x. Now, because I made u, I have to unmake u. So that would be 1/3 times ln of x to the negative 2 over 3 times 1 over x. Now, if you wanted to simplify it, the simplification would look like this. So you'd have, what is this? It's going to be 1 over 3x ln of x to the 2/3 on the bottom. I would say don't do this. Don't do the simplification, but if you did, that's what it'd look like. And please don't try to rationalize any of these. You rationalize them, the grader's going to have to sit there and redo them. And while I am pro wasting grader time, it will also waste your time on the test, and I'm against that. All right, so how do we feel here about 2b? It's got this kind of power rule thing that I have to convert first. Okay. All right. All right. So while you guys are thinking about that poll, let's move on. So the journey of x here. Well, x is going in 2 places. And here it's getting exp'd of x. Here it's doing nothing, and then it gets quotient. Right, so the thing that happens last is a quotient rule. So what I'm going to do here is the derivative of the top times the bottom minus the top times the derivative of the bottom all over exp of x squared. All right, that's the quotient rule. And what I'm going to get is 1 times exp of x minus x times exp of x all over exp of x squared. And that's the final answer. Now, I'm going to simplify it right now. I'm going to factor out the exp of x. This is not in any way, shape, or form required, and I encourage you not to do it. But I'm going to do it because I'm going to show you something later. So I'm going to go ahead and do this, and what I'm going to get is I'm going to get e to the x times 1 minus x all over e to the x squared. This e to the x is going to cancel with one of those, and I'm going to wind up with 1 minus x over e to the x. Now, again, there is no need whatsoever to do that. I am showing you something because I'm about to show you how to do it the other way. So 1 to 5, how do we feel about this? Let's see, multiple choice. This would be 2c. Little quotient rule problem in there for you. You can do it as a product rule. In fact, we're about to do it as a product rule. Okay. By the way, I did them as product. I spent like the second time I took calc, I passed it well. But I spent the entire time never using the quotient rule. I always used the product rule in the second round. I was just like, I can't remember this order. I'm dyslexic and I always get them backwards. So I'm just going to use the product rule and the chain rule. You can do that. No. So so the question was, and it's not a stupid question, it's a good question. So there was a question about, so e to the x squared is actually equal to e to the 2x. That is true. Okay, you could do that. So that means that exp of x squared equals exp of 2x. It does not equal exp of x squared. That's something a little different. Okay. And if you need convincing, put in the number 3. So let x equal 3. E to the x squared here equals e to the 9th, whereas e to the x squared is going to equal e to the 2x, which equals e to the 2 times 3, which equals e to the 6th. And since e does not equal 1, those two numbers are not equal. That is a very good question. So no, it is not the case that e to the x squared equals, e to the x squared. One of them equals this, the other one equals that. But it is a good question. And since e does not equal 1, those two numbers are not equal. Or 0. All right, any other questions about that? Good questions all. Okay. All right. Well, this is actually the exact same question as that one. This and this question are exactly the same. This is just written in product chain form. This is just written in quotient form. So if I wanted to be a real smart aleck, what I would do is this. I'd go equals 1 minus t over e to the t, c part c. Right? And the grader will write smart ass. But, it's actually right. And it's a fair way of doing it because they are the same thing. But let's actually do it like we should have done it. So let's invest here in the journey of X. Or of T in this case. So what happens here? We got T in two places. We have T and T. Now the first T just goes down. The second T here gets negatived. And then e to the negative T is taken. And then they get jammed together as a product. So the last thing out is a product, chain, etc. So the thing that's on the outside is a product. And I'm going to work outside in. So the first thing I'm going to do is a product rule. Okay, so d over dt of the first times e to the negative t plus the first times d over dt e to the negative t. Now, this one's going to become 1. Now, this right here, I've got an e to the negative t. That means I need a chain. All right, so I'm going to have a chain here. I'm going to have, this was plus, and for some reason it decided to switch markers. There it goes. So I'm going to have a plus, oh, because I did it when I did that. Okay. Plus t, baggage, times d over du of e to the u times d over dt of u. All right, that equals e to the negative t plus t, baggage, times e to the u, which is the derivative of e to the u, times the derivative of negative t. That equals e to the negative t plus t times e to the negative t times, and notice what I've got here is a negative 1. And that's the answer that I'm looking for. Now, I'm going to simplify because I want to show you what happened if I did it the other way. Don't do this. You don't have to do this, but I'm doing it anyway. Because I want to show you something. All right, so let's factor out the e to the negative t there. So we're going to get e to the negative t, 1 minus, because there's a minus sign there, t. And that equals 1 minus t over e to the t. So I got the same thing as if I did it in C. So both answers are the same. All right, how do we feel about part D there, 1 to 5? Let's see here. Oops, wrong button. Pulling multiple choice. Stop. Okay. That one's a little harder. It's got multiple things going on. By the way, this t times e to the negative t business, or t over e to the t, this is a very important function in math. It's especially important in statistics. It's one of those cumulative density function type things. It shows up all the time. So you should definitely know how to do that derivative one way or the other. You can either translate it to a quotient, make it a quotient rule, or you can do a product with a chain in it. Okay, but that's a very important function. Okay. It shows up in pharmacokinetics all the time. So if you're going to medical school, you get to see that again and again and again. Because it describes the way, with constants and everything in here, it describes the way that drugs work in the body. The way you get the sharp spike, and then the liver kind of does it linearly, and then it takes over and it kind of processes it. It really describes what's going on with drugs in the liver and the body and everything like that. So you might want to know how to do that. Okay, so here's our journey of X for this one. Okay, so the first thing that happens to X is it gets EXP, is the exponential function is taken of it. And then the exponential function is taken again. Right, so this is exp of x, and this is exp of x. Fun. All right, so what I'm going to do is I'm going to call this whole thing V. I could have called the whole thing U. In fact, I will do that. So I'm going to call this V, and I'm going to call that U. U. I'm going to call this U. I'm going to call that V. I'm going to call that V. All right, so what I'm going to do is I'm going to call this whole outer thing U. Doesn't actually matter what I call them. All right. So what I'm going to do here is I'm going to just do the chain rule. I'm going to treat this whole thing as a block. I'm going to do d over du exp of u times d over dx of u. And then I'm going to evaluate. Exp of u times d over dx exp of x, exp, the whole u, exp of exp of x. All right, well, I got another chain. I'm going to call this V. So I'm going to wind up with exp of u, carry my baggage, times chain d over dv exp of v times d over dx of exp, of v. Getting ahead of myself. That equals exp of u times exp of v times d over dx exp of x, which equals, now this right here, I'm going to evaluate this. I'm going to sub in my baggage, exp of exp of exp of x. That became that. Times exp of x times exp of x. And there's my final answer. 2 chains. How do we feel about that one, 1 to 5? All right. Okay. A little bit looser on the double chain. If you just keep to the process, right? The first problem was this. When I broke it up, I got a new problem. So this became my problem. This becomes my baggage. This becomes my baggage. This is still my baggage. I do another chain. This becomes baggage. Now I've got a new problem. And then I just subbed in everything, and I did it all in one line because I was running out of room. Okay. All right. So let's look at the journey of X on this last one. So I've got X is going to go in twice. I know that U moves with X, but that's all I know about it. So here X becomes U, and I don't know anything about it after that. Here's this one here, it becomes a sine of X. And then U over here gets squared. And then they get jammed together as a product. So what I'm going to do here is I'm just going to go, okay, well, d over dx sine of x times u squared. I'm going to go ahead and do a product rule first. This is a product. This will be a chain later. So what I've got here is I've got, okay, the derivative of sine times u squared plus sine of x times the derivative of u squared in terms of x. All right. This right here is easy. Well, this is baggage. Now, I've got d over dx of u squared. I'm going to need a chain here. The u's actually already written for me. So I'm going to have d over du of u squared times d over dx of u. It's cosine of x times u squared plus sine of x times 2u times, and I can't do anything with this. This is a times, by the way. So this just becomes du over dx. And that's it. There's nothing more I could say. I can't sub back in because I have no clue about what's going on. And that's it. I just have something unevaluated. All right. How do we feel about that one? 1 to 5. That one's a little harder. That one's a little tricky. You have to get used to this idea that I may just have something I can't say anything else about. That's kind of hard. There's no number there. There's no x term. I just have a u. So I have a du over dx in the term. That's kind of tricky. How did I get that? Well, that came from the chain rule. That's a good question. So someone asked, could I explain it again where I got that? So the chain rule says the following, right? dy over dx equals dy over du times du over dx. Now, this product business here, that's fine. But here I've got d over dx of u squared. So here I've got y equals u squared. And I want the derivative in terms of x. So dy over dx equals dy over du times du over dx. Now, I know that dy over du, I just take this derivative, 2u. But I still have to account for that term. I have no idea what it is. I just know it's there. And this is not an uncommon situation in science. It is not uncommon to be stuck with a term that we don't know. And this may be determined experimentally, right? I could have a large differential equation like Boyles Law. Okay, let's do that one real fast. What's Boyles Law? Does anyone know it off the top of their head? Pressure. V is volume. Right, temperature is constant. So what does Boyles Law say? Anyone remember Boyles Law? No? It's very important to scuba divers. As pressure increases, volume decreases, and vice versa. Why is it important to scuba divers? Because if you hold your breath at 100 feet and come up, your lungs explode. Because the volume increases. Boyles Law says that C, there's some constant so that C equals pressure times volume. Now, I may not know what C is. But the point is, it actually doesn't matter. Because watch what happens when I take the derivative of both of these in terms of one of the terms. So let's let P drive. So the question is, what happens to volume? What's the rate of change of volume? Or the rate so let's do the question. Let's just let P drive. So what is the change in volume with respect to pressure? So I'm going to do d over dp of both sides. Now, I'm going to wind up with a 0 here because this is a constant, which is nice. And the point is that the constant, I don't have to solve for it. It goes away. And what I wind up on this side is I wind up with a d over, I do a product rule. So I wind up with a d over dp of P times V plus d over dP plus P times d over dP of V. And what I wind up with then is V plus P times dV over dP. And together that implies, with the 0, so I've got 0 equals V plus P times dV over dP. And then I could solve for this variable, and I wind up with, I move the V over to the other side, so I wind up with negative V over P equals dV over dP. And the point is that I may have experimental data on this bit here. Okay, I may not know what dV over dP is, or I may have experimental data on this, and I want to find that. I may not know what this is explicitly, but I may have experimental data on it. Okay? So I can leave these terms unevaluated. That's the point. Okay, I could do the same thing with Guy-Lussac's law, and all these other. I mean, I could do the whole thing with the noble gas law, with the ideal gas laws, right? I can do the entire combined ideal gas law like this. I could talk about Dalton's law, which relates partial pressure of gases. All of these things that are important to scuba divers, I know. So when we teach dive masters at the shop, they're always like, Scott, I need you to come in and do the physics portion, right? Because I do the math. And then I confuse people. But then they passed the physics, so, what do you want? Are there any other questions on this? Okay. So let's turn to the problem set. Now, on Monday, especially given the amount of time that's left, let me go ahead and go ahead and switch to your top problem set. I want to go over the first part of problem set 6. And I will post this. I'm sure some of you have already seen it. Not this entirely, but I will post the work that I'm about to show you. Right here, for part C on number 1, I've got to compute the equation for the tangent line. So what I need the slope. Now, the first thing I'm going to do, the first answer here is I'm going to solve for y. So I'm going to get y equals 1 over x squared to the 1/2, which is the same thing, which is the same thing as the square root of 1 minus x squared. Now, when I take the derivative of this, the work is here, and I'm going to give you the work on, as I said, I'll give you the work as a picture. But this is what I wind up with here. I wind up with y equals this u, and then I do a whole bunch of chain rule stuff, and I wind up with this answer. Then when I sub in the square root of 1/2, I wind up with an m of -1. Okay? So that's how you do part C. Are there any questions about that? All right. So that's the big idea. Let me see. Let's see. I saved that somewhere. Let me see if I can find it. Here it is. So here's the, I'm posting in chat right now the link for that one. So there's the link for all that work to get to M. And then you just sub it in for the tangent line, and you wind up with -x plus 2 root x. I actually only care about that first line there. And I just posted in regular chat in Blackboard Collaborate Ultra. I posted the work to get to there. Any other questions about this? Okay. So we're going to break out into groups. If you are working in Discord, make sure you're working in my Discord server on one of the rooms. If you are not working in Discord, if you're not there, make sure if you're working in like one of the other things, like GroupMe or whatever, make sure that you stay in Blackboard Collaborate Ultra so I get you for the attendance. You may switch groups in Blackboard Collaborate Ultra. And let's get started on the problem set. Let's see, I got 5. Allow attendees to do that. Randomly assign. Oop, people are leaving faster. I only need 4 groups now. I will start groups.